Okay, last day of the conference. 2 more talks to go before the lock note. I hope you are ready to learn something new, because I'm going to talk to you about content security policy and take you all the way from newbie to advanced. Now, let me first see where you are on that scale, because you can be anywhere you want, and I'll hopefully have something to tell you. So, who has never heard about the content security policy before? Okay, a few. Who has seen one, seen the effects of one? Okay, who has worked with one or seen reports from one? Who has taken one quite a way, like implementing or maintaining a policy? Still some, okay. So you're quite spread out. So even though I'm going to take you all the way to advanced, it won't be too complicated. It's going to be like when I took this picture. I'm not a scuba diver. And like with scuba diving, you're swimming down and you're staying there. I'm not going to stay down in the complicated stuff. I'm also not a snorkeling guy. I can't stand the snorkel being filled with water. But I'm a swimmer, and I'll swim down and stay there for a while and then come up and breathe. And it's going to be pretty much like that here as well. Going to go into the depths of a few things, but if you drowse off for a second, we'll quickly be up and breathe again. So apart from being a good swimmer, I'm also one of the top answerers for content security policy questions on Stack Overflow. My name is Halvor Sakshaug. I work with application security at PG Forsta. Occasionally, I do some writing on my blog, and you can find me on Blue Sky. Content security policy, or CSP, as I will typically be abbreviating it to, is a policy that we send to the browser, and the browser will enforce you and protect your app or your website in your user's browser. And why do we want such a thing? Well, the thing that I will focus on today, and which is really the most important thing and the main use case, is protecting against cross-site scripting. It's kind of the last defense, and it's really good at it. But you can also use it for framing or to prevent framing and exfiltration and unwanted sources. But I will give the most focus to XSS. There could be some other reasons, what a psychologist would call outer motivations. That could be audits, pen tests, and clients saying you should have a content security policy. And I think it was about 6 to 8 years ago, I saw the first such requests. And ever since, I've just seen more and more and more every year, and they're also getting a bit more nuanced and detailed. Now, there's a final reason that appeared this year, or it was enforced this year. PCI DSS, the payment card industry, they have a new standard, version 4, and in effect from 1st of April. Says that if you have a payment card page on your website, you need to be in control over the scripts that run on the page, and the best way to do that is with a CSP. So what I'm going to say today is, first, I'll give you some introduction to CSP with all the terms and variations, because there are a few things you just need to know to understand it. I'll give you a demo of policy development. I'll go into the depths of preventing cross-site scripting and how we can do it. I'm going to talk about some gotchas, so you don't stumble in the same ways as so many others. I'm going to cover reporting. And finally, I'm going to show how not to make a policy. So first of all, the policy is typically set as a response header. So it's just a string. It consists of multiple directives. The directives are listed first with a name. And just for the convenience, I will put those in green. There are also different sources, 0 or more sources. And I'll also go into some depths on the different sources. And also, if there are some resources that I refer to, URLs, I have put all those at the final slide, so you don't need to take pictures of them. You can do that at the end. So with HTML, if you put if you reference some source in an HTML document, like an image or a font or a style or a script, the browser will happily load it because that's the way it's made. So if you have like a relative URL, you'll load it from the same server. If you have an external source, like absolute URL, in this case, the xyz.com, the browser will load it. If you have some inline stuff, the browser will process that. If there's a data URL, browser will display that image in the data URL. So that's how HTML works. No restrictions. With CSP, we want to go the other way, or put restrictions on this, and say what is allowed to run on this page and what is not. So let's start out being super strict. Setting the directive default source, which is like a catch-all if nothing else is defined. And we say none. And now I colored everything in red, meaning this is not loaded. It's denied. Compared to the green, where it was allowed. So of course, if you do this, it's like a time machine. You take your web page back to like 1996, where it's pretty much like text and links. So that's probably not what we want. So we want to, enable the stuff that we want on this page. So we change from none to self, which is pretty much like the same origin. So we allow all the relative URLs. And then we can add even more to this directive in the policy. We say also the host xyz.com is allowed. And now we see more and more stuff is allowed. I'll add more. Now I'll add another directive. I'll add the style source directive. That governs the styles. And as you see, styles now have self. So we see we still have the relative URL in green. But now xyz.com kind of dropped out. Because when we implement style source, styles will kind of end up there. They won't go look for default source anymore. And then we'll add another thing to style source. We'll add unsafe inline. And now the inline stuff is allowed. Let's take another variation. We'll remove default source. And now we're only restricting style source. Everything else is like before, the default HTML way of doing things. So now we only restrict styles, but we allow self, which is like relative URLs, everything on the same origin, and inline stuff. And as you see here, xyz.com is not allowed. CSP comes in 3 different levels, or you could call them versions, because that's what they really are. We are now on level 3, and have been for a number of years, even though the specification is still in draft. But now we don't really need to care about the older versions anymore, because the browsers pretty much have implemented level 3. Firefox is just missing a few minor details. Disposition is another thing we need to know about. You can either have content security policy, which is the enforced version, or we can have content security policy report only, which is a non-enforced version, which just reports, so you know what would go wrong if you enforced it. Here's the difference. If you look at the picture on the right, that's how the NDC Oslo webpage looks like. But on the left, I have enforced the policy with font source none. And as you see, the fonts or the text, which isn't images, is now quite different. It's the default font in the browser. So we prevented it from loading the font that it wanted. And you can look at the error message at the bottom from the console. It says refused to load the font because it violated the CSP. On the right hand of the screen, you see report only. It doesn't do anything visually. So, but if you open the console, developer tools, you will see something. You might see an error, which really isn't an error, but it says report only. And I think recently they started coloring these a bit different. So there are a lot of directives in CSP. And these aren't even all. And they're also grouped into different classes. I'll mostly focus on the fetch directives and also tell you about some of the others. And as you saw with the example, there are fallbacks. And here they are. As you see, the fetch directives and worker source eventually falls back to default source. So if you implement default source, that's kind of the same thing as implementing all of them. But you likely want to make it a bit more fine-grained. Now I said this isn't all, so let's add a few more things. Scripts and styles, you can be more specific. You can split it into attributes and elements if you need to. Actually, the specification says if you don't need this, don't do it. But it's quite useful when you get the reports and you can see that something came from an attribute or not. So you might ask, so what do all these different directives control? So here you can see all the tags and all the script constructs that are governed by the different directives. And you might be forward thinking and say like, okay, so what if there's something new? If there's something new, it's most likely sending or receiving data. And then it will be connect source. Down left, that's where all the send and receive data goes. So anything new will go there. And if that isn't implemented, it defaults to default source. Now this isn't even all, there is more. There are some experimental directives. They're only implemented in Chromium. If anyone hasn't added support recently, I won't be covering them in this talk. Sources. So we had directives, and most of the directives have some sources. Some have some really strange sources. But now I'll show you what are the sources for the fetch directives and some of the others. So we have some keywords. We have self, which I've said before is almost like the same origin, but it's just almost. It includes upgrades, meaning if you are in an insecure scheme, like HTTP, you will also include HTTPS, the secure version. And if you are on a non-default port, it will include the default port for that scheme. And then we have none, which is just an explicit way of listing nothing. As you saw in the example with xyz.com, you can have a host. You can have just the host, you can have the scheme in the host, you can have a path included, you can have a port, or you can have all of them or some of them. But of course, the host needs to be there. You can also have the more broad scheme source. Could be very broad, and in some cases that could be insecure, in some other cases that's just what you want. Scripts and styles have even more keywords. I'll come back to most of these later, just kind of showing you here that we have like some unsafe inline and hashes, we have report sample, hashes and nonces, strict dynamic, unsafe eval, and WASM unsafe eval. Probably sounds quite strange, all of this, but I'll give you some understanding of all these things. Just let me point one out here. It's report sample on top here. That's not controlling anything. That's more like a flag saying, oh, if there's a violation with a style or a script, include a sample in the report so I can know which script or which style violated, so you can more easily figure out what happened. I said before that CSP is typically set as a response header. You can also set it in a meta tag, and if you read online and Google CSP, there'll be a lot of people saying that you can set it as a meta tag. Yes, you can. You can also walk out on a cold day like this, or in the winter time here in Oslo, like without putting on proper shoes or clothing. You can, but you will typically only do it for a short time, and you see very few other people doing it. And that's pretty much how it is with the meta tag. It's also a bit more restricted than setting it as a response header. And response headers you can set in a lot of different ways. Load balancer, proxy, web server, code. So where do you want to set it? Pretty much depends on who's going to maintain it, who's going to change it. Is that going to be operations, or is it going to be developers, DevOps? Who's going to do it? And how quickly do you need to change it in case you have messed up? That's one thing you need to consider. The other thing is, does it need to be dynamic? Because if you can't have a static one, you'll likely put it in code or close to code. So let's us have a demo. We have the NDC Oslo webpage, and it doesn't have a CSP, unfortunately. So let's make one. I told you how you can set a header for this. I'll show you a totally different way. You can't use it in production, but it's perfect for developing a policy. So if you go in Developer Tools on the Network tab, so you see the response headers. You may not know about this, but you have this little pencil that says Override Headers or Override Header. I'll click on this one, and I will go down to the bottom. Here I have this button saying Add Header. You can also just override something existing. So I will type in Content Security Policy, because that's what I want. I will go super strict from the beginning and say default source none, which means, yeah, pretty much nothing is allowed. Hit enter and I will reload the page. And yeah, we got back to the 90s. Very beautiful web page. Oh, isn't it beautiful? And we have 108 errors that we didn't have before. So obviously something went very wrong. Okay, now I will be cheating a bit. Or not cheating yet. First I'll show you how to really speed up, because I could go back in the network tab, I could find the request, I could edit the headers, but let's do it better, in a better way. First time you set up override headers, it asks you where to save the data. So I have the Chrome overrides folder. Now it generated ndcoslo.com. Has this header file. I'll open it with just Notepad. And we have this file here. It applies to index.html. I'll just make it work for everything in case I should need that. And this is what it wrote. Content security policy, default source, none. Okay, I will add a few more directives, all with self, which means all the relative URLs will now load. So that's scripts, styles, images, fonts, and connect, which is reading, sending data. Okay, we'll save it, and we'll refresh. Now, CSP is dangerous. You can kill your page. Now we didn't just go back to the 90s. I think we're back to the Stone Age, at least pre-internet. So, yeah, this happens every time, so I'm prepared for this. I think a script trying to read something that should have come from an inline style. But that inline style is not permitted, so everything stops working. So I'll need to add something to style source. I'll add unsafe inline. And then we'll try again. Yeah, that looks better. Maybe you can scroll down and see what it looks like. Yeah, we're getting there. Okay, let's start processing the console errors. Oh, we now have 146. Yeah, not bad. We're increasing, but there are other reasons for that. Okay, let's look at what we got. So first, there's an inline script. So actually, the error message tells us what we can do, and it suggests different things. We can add unsafe inline. Don't do that for scripts, because then you have no protection against XSS. But it also says you can add a keyword or a hash or nonce. So let's take this hash. So what the browser has now hashed the inline script, and it's just shown us the value, so we can put that value directly into the policy, which is nice. Oh, that was not copied. I have to copy again. So we got the hash. Okay, it's also trying to load a script from js.hsscripts.com. I'll take that later. It's a rabbit hole, so well, defer that for a bit. It's trying to load media. This is actually the video. So we'll copy that one as well, and we'll need to add another directive, media source, and add it there. Okay, it's trying to load images, 136 of them, also from CDN Sanity.io. So we'll add that. Oops. There's image source, so we'll add it there. And let's see, let's just scroll down and see it's all CDN Sanity.io. Yeah, I'll just scroll down until we have some different indentation, see if it's still CDN Sanity.io. Oh, need to scroll again. Yeah, all the images were from there. And then we have refuse to connect to URLs. I'll just keep copying. You shouldn't just add things uncritically. You should think, do we really need this? Do we really want this to be allowed? But then for this, we'll just add everything that seems to be here. And if you aren't running really bad things in your browser, if you have a clean, up-to-date system, you are hopefully not have anything that alters your page. And it's probably okay. So I think we got all the different connects. And then we have one more thing. It's a style sheet from MailChimp. Let's see, there was a style. Put it at the end of that one. Okay, let's see what it looks like now. Lot better, only 2 errors. So that's good. First one is Google Tag Manager. Don't add it. Because if you do that, you'll need to add another one, and another one. And then you have suddenly users in different regions of the world, and they will prompt you to add another one. Instead, go look at the Google page about this. This is very common, that's why I'm covering it. So they have a very good page saying if you're using Google Tag Manager and you have a CSP, this is what you need to know. And this might change. This page might change with time. It has in the past. But they're saying things like, okay, so if you have a nonce, if you're trying to make it really strict and you have a nonce, you can pass it into the script like this and things will be a lot better. Or if you have, let's see, custom JavaScript variables, you'll need this. Preview mode, you'll need this. Google Analytics, you'll need this, like 3 different directives with some sources. If you have Google Analytics, this is what you'll need. So it says script source. Oh, I'll go back here. Get them all on one screen. So we'll need something for script source and image source and connect source and frame source. Quite a few sources, but this isn't everything. If you look at this thing here, which is a bit strange, Google top-level domains. So if you have Google Ads or Google with Google Signal, then you might need a lot of these Google top-level domains. And they even made a list here of all of them. Beautiful list. If you want to have full support in all countries and regions of the world, you'll need this. Last time I counted, it was about 174, I think. So, yeah, you might want to or not want to add all of these. Not only do you need to add them, you actually need to add them twice. So that's like 350 sources for your CSP if you want to have full support. You may not want that. Okay, so let's go back and just ignore Google Tag Manager. Look at the other one, jshscripts.com. Now, we'll copy this one. I told you earlier, if you remember, this is a rabbit hole. So let's see what happens. I added it. We'll reload. What's that? It's not the same one because now last time it was js.hscripts. Now it's js-EU1. Another one. So this is probably not what we should do, but just for the sake of the demo, I'll show you that you can use a wildcard. And I will also talk about wildcards. So when we add this wildcard, we'll allow both of these subdomains. And we'll also allow subdomains of the subdomains any level deep. But we do not allow hs-scripts.com because that's not the subdomain. So if you want both of those, you'll need the wildcard.hsscripts.com and hsscripts.com. And you can't have, in this case, hsscripts.asterisk for the wildcard. That would be very useful in the Google case. Yeah, very useful, but it would be very insecure because there could be another top-level domain and somebody could register that. So that's not allowed. But you can also do a wildcard for port. And you can also have just the wildcard character. Then it's a host wildcard. Some people will say, if you want to allow everything, just add the wildcard alone. It will not allow everything. For instance, for images, if you do it, you'll add. It's a host wildcard, so we'll add all hosts, but if there is a data URL, won't allow it. For paths, the wildcard character is that you end with a slash. If you end with a slash, everything including up to that point and something else after will be allowed to run. If you don't end with a slash, it's just that specific file that you listed. So, did I save it? Yes. So let's try and see what happens. I'll need to expand it because now we got several scripts. So we still have the Google Tag Manager. I allowed all the HS scripts. So now we have hsanalytics.net. We have JS EU1 use messages, HS collected forms, HS banner. Yeah, it's a rabbit hole. I won't go deeper into that. So we're getting close to having a good policy. Should probably visit all the other pages if I want to have one policy for the entire site. And should also check if the cookie pop-ups and things like that are supported. But we're getting fairly close and didn't take that long. So now to finish this off, let's copy the policy, take all of it, and paste it into the CSP evaluator, which will tell us if it thinks it's good or not. So we'll check it and go further down, and it says default source, all good. And most of the other sources, all good. Script source, we can expand. I think I'll have to make this a bit smaller to fit in. So the hash, it says, that's all good. Self and the wildcard, it doesn't react to the wildcard. I think it should. But it says that, well, I can't really know what you have here. But it's telling us about the typical problems of endpoints. So if you have JSON-P that can reflect scripts, older Angular JS can be problematic. And also, if you have user-uploaded files, there are certain things. Script is like the most dangerous thing. So, yeah, you need to know what's there. And having a wildcard for subdomains, it's kind of dangerous. People can actually hijack subdomains. And there could be serving things you didn't think about, or tomorrow things are served there that you didn't think about. So it also says required trusted types. That's one of the experimental headers. So let's go back here. Talk about hashes, because that's a source. You saw a hash because we used the one that the browser gave us. If you have some dynamic code, you might need to compute it yourself. It's actually not that hard. It's a few lines of code. So you take what's between the script tags, take a UTF-8 representation, hash it, base64 encode it, and just put it into your policy. Same way as copying from the browser. Or, yeah, of course you do it quite differently, but same idea. Just put it in there. In CSP level 3, which we are at now, you can also use a hash for an external file. And in that case, you won't get the hash from the browser. So if you Google it and ask, how can I do that? How do I get the hash? It will say, well, you need to download the file, you need to run this PowerShell command or some other hasher. And you get it. Or I'll tell you how to do it in the easy way. Add the integrity value, or integrity attribute on the script with the dummy value. And then the browser will say, hey, your integrity value is wrong. It's this one. You should use this one. And thank you very much. You can put that into your policy. You can also use nonces. They are, as you hopefully know, a number used once, or pretty much a random value. The important thing is you should only use it once. So you need to change this for every page load. You just need to put the exact same value in the policy and in the nonce attribute on the elements. And then that will be allowed. Nonces, you'll need one for each page load. And of course, that requires you to have a dynamic policy. Hashes, you'll need one for each script or style, which means you may need a lot of them. But maybe you shouldn't have like 20, 30, 40 hashes, because it will get messy, and you should make a reference on what each of them are for. If there's a dynamic script that changes, you'll need to recalculate, as I just told you. Nonces can only be used on tags. Hashes can also only be used on tags, at least how it was before. But you can also add something called unsafe hashes to enable it. And as you've probably seen now, we have a lot of unsafe on these keywords. It's trying to tell us that some things just aren't safe. But there are very different levels of not being safe. The unsafe inline for scripts is very unsafe. The unsafe hashes is still a bit unsafe because this is what you can do on an attribute, and because you typically need this for attributes. You'll need to, because the hash you can use on all the inline scripts, but if there are hashes or if there are attributes or JavaScript navigation, you also need to add unsafe hashes to make it run. Because in those cases, we typically just have a reference to some other function. And the unsafe part is typically that you could run these out of order or in unexpected places, like approving something or issuing a transaction or yeah, whatever. And that could be unsafe. Now I'm going to talk about strict dynamic, because it's a bit of a different paradigm that you can use for scripts. And I've said put something in traditional. It's not really kind of the best term, but I didn't find a better one. That's the one I've been showing you, where we have like keywords like self, we list hosts, we can use nonces and hashes, just as I've shown you in all the example and demo. This is what you will do for most of the fetch directives and a few other directives, and you can do this for scripts. But in scripts, you may also want to do it a different way. Because sometimes you don't trust a certain source. Because there could be other things, or you know that this source has, something could be problematic. And then you can say strict dynamic instead. And that, when you do that, the only allowed sources are nonce and hash. So strict dynamic is just another keyword that you add. It's backward compatible. So if you're on CSP level 2, you just defer to the traditional one. But on CSP level 3, which is the one we use now, this is a way that you can say, okay, I have listed scripts with hashes or nonces. These are the ones that I trust, and they are the ones I allow to run. But not only those, also those that they load. So in our case here with the jshscripts.com, had we used strict dynamic, we would not have had to add like the EU1 versions and all the others, because we only would need to allow the first script with a hash or a nonce, and then voila, all the others would be automatically loaded. So it's a totally different way, but it's also backward compatible. But you have to do it the right way. You have to include other scripts by adding them to the DOM. You cannot do that by adding another tag, unless it's allowed by the hash. So, a bit of a recap. and summarize how you can allow the different sources. First, URLs. So if we have like regular HTTPS URL, you can add it as a scheme. It's very broad. You can add the host. And if you are in styles or scripts, you can also use a nonce or a hash. And if you are using strict dynamic for scripts, you cannot use screens or hosts, and you are limited to those on the right side, the nonce and the hash. If it's a data URL, it doesn't have a host, so that doesn't apply. You can't use that, but you can use the others. If it's a blob URL, that's not meant to be static, so a hash doesn't make sense. Host doesn't have a host, but you can use the others. If there is inline script or style, what should you do? I think the best thing is to rewrite. If there is like an regular inline script, you can use nonce, you can use hash, and you can always use unsafe inline. But don't do that for scripts, because then you really have no protection, because that's typically how every cross-site scripting attack starts, by adding some inline scripts. And if you add unsafe inline for scripts, then you allow the attackers, and much of your work on the CSP is futile. Well, you can still prevent some exfiltration and use some of the other features, but the value really goes down. For styles, it's a bit of a different story. There is a very good blog post by Scott Helm, who's often been at NDC, titled, "Can you get pawned with CSS?" And yeah, there are some ways that you can get pawned with CSS. It's mostly about exfiltration. So adding unsafe inline for styles is not that bad. But avoid it if you can. But if they're like we have 80 or so problems with unsafe inline here, yeah, maybe you don't want to rewrite everything, because you still get a lot of security improvements by narrowing down other things. Dynamic string evaluation is also blocked when you implement a CSP. That means that you can't have a function that evaluates a string and runs that as code, like you will do in eval, a new function, set timeout, and set interval. You can still use those functions if you supply them with a function. But if you give them a string as the first parameter, that's a violation of your CSP unless you have allowed unsafe eval. So ideally, rewrite it and don't allow it at all if you pass any user input to the eval function, because then you're in for massive trouble. It's kind of a bypass of your entire CSP. There was another keyword, if you remember, called WASM unsafe eval. It's somewhat related. It's about compiling WebAssembly and running it. I won't cover that. So now I've kind of shown the different ways that you can allow and disallow scripts to run, because sometimes that is really hard. And that's the main problem is typically inline scripts. And it's very often legacy code or frameworks that very much likes to add stuff inline, because that's convenient, that's how we did it. Or it could also be third-party code doing the same thing. Not all third-party code is compliant with CSP. And you might need to replace or rewrite or fork or something to make it work with a strict CSP. Eval, just said, could be another problem. Might need to rewrite stuff there as well. Can realize that you are depending on some bad sources that you might want to replace. That might take some time and effort. Could be client content. I've struggled a lot with this because we have allowed client content that they can build their own content, their own HTML with a lot of different things, scripts and styles and whatnot. It's quite hard to restrict it, but yeah, with some effort, it might be possible. And then finally here, your public web page. You know, the one made by marketing that is probably based on some CMS like WordPress with like 1,000 plugins and trackers and all the other marketing stuff. None of that is typically CSP compliant because no marketing department ever asked about that. So adding a strict policy on the company's public webpage is super hard. So if you see some statistics that the adoption of CSP is very low on the top X thousand web pages of the world, it's typically because those things weren't built for it. But if you start looking into like banks and financial institutions, you'll probably see a lot better adoption. But sometimes it can also be easy on a lot of single-page applications, unless they do some funky down the road and import a lot of stuff from here and there, which some of them do, but most of them don't. It can be really easy, just like make the first page work, and it's a breeze. Also, if you add a CSP from day one of a project and teach the developers how to work with it and don't just enable it when they have some problems with it, then it's also a lot easier. It's often really hard to come after, and then you need to change everything and need to replace stuff. Yeah, get in from day one. I tried this and it really worked. So I focused on scripts, which is one of the most important things to restrict. But what else should we restrict? Well, the whole thing is about restricting stuff. Object source is something you really want to restrict because it can run scripts. And in most cases, you're not using it, so just block it. Style source I already covered. Try to be strict because it's good, and there are some ways that you could, exfiltrate data. Base URI, there's a directive called that, and that's kind of governs where relative URLs can load their stuff from. If you don't need it, restrict it. Default source should be restricted as well, because if there's a directive you haven't implemented, it will fall back to default source, at least all the fetch directives and worker source. They will fall back there, so just restrict it, you're better off. And then finally, frame ancestors. Restricting framing, right? That's who can frame your page in an iframe on their page. This is just like Xframe options, which you hopefully have used. This is just a lot more flexible, so you should use this one instead, because if your browser sees CSP frame ancestors, it'll just ignore Xframe options. So now we're over in the gotchas. So we have frame ancestors, which I just said has a fallback to Xframe options. It's about who is framing your page. Not to be confused with frame source, which is about the frames that you put on your page. So this is about your content on your page, not about who's framing you. And this one has a fallback first to child source and then to default source, where all the other sources for the content on your page are. So just remember that these are very different things. And a lot of people confuse some of the directives with other headers. And so we have the one with the use case of preventing framing, which I just covered. So they are like very similar. We just have a more flexible version now. And then we have prevent XSS. And if you have been here and your ears have been open and you're in awake, you know that, well, we need to restrict script source or the derivatives of it. It's like script source element or script source attributes. And object source. You may be thinking, well, yeah, we do this with XSS protection. No, you don't. Because that header has been dead for a number of years in all major browsers. So you can just remove it. You can force HTTPS in different ways. You can do it on the current page with the directive upgrade insecure requests, which will turn all your HTTP into HTTPS, all WebSocket, like the WS into WSS. Everything on your page. Or you can use strict transport security, which works on the host or the domain, depending on if you've preloaded it or not. Restricting data sharing, we can do with connect source. It's about the current page, what can be sent and received. The server can set core setters like access control, allow, origin, restricting from the server side what will, how the browser should behave when data is sent cross-origin. You can have multiple policies. It's a bit of an advanced use case. So you typically won't need it starting out, but you can have multiple policies. And a lot of people that want to add a policy, they create one, but then they inadvertently also enable the default policy. And it's the Swiss cheese model. All content needs to add all policies. So if something is not allowed by a policy, you can't add another policy to allow it. It has to pass all of them. Reporting. Reporting is configured by one of two directives, or both of them, called report URI and report to. So these aren't restricting anything. These are just telling the browser, if there's a violation, should I send a report? And if so, where should I send it? So you can do it with just a URI to your reporting endpoint, or you could use report to, where you have to specify that in a separate header. Support doesn't look too good, but there's a fallback, so you can implement both, and the browser will take report to if it understands it, otherwise report URI. And I think report URI will be usable for a number of more years, so you can stay with that if you want to. When there is a violation, you'll get a report to send to the reporting endpoint. And this is the information that will be in it. It will have the document URI. Where did the user go? Maybe before all the eventual redirects that could have happened. It will list the refer and the status code. This could be useful when you try to understand the report. The source file is, where were we when the violation happened? In this case, there's a script loaded from googletagmanager.com. That script caused this violation when it hit the blocked URI. In our case, the directive is connect source, as we'll see below. It's trying to send or receive data, and it's blocked. It also shows us the original policy. Really useful if we have multiple policies, or if we didn't know that we have multiple policies, or if something happened to the policy. Because there are actually people changing policies. I'll come back to that. Then, which directive? Specification says that these two fields should be identical. So I don't know why, but yeah, backward compatibility, they're the same. Disposition, enforce, could also be report only, but in this case it's enforced. Line number and column number, helping you understand where in this script did this happen. And then finally, script sample. In this case, it's empty because this was an external script. Had it been an internal or inline script, you would have gotten the first 40 characters. So reporting is great. I have used it a lot and also abused it a lot. You can read about that on my blog. It allows you to quickly develop a policy. Now, in the example that I gave, the demo, I used content security policy, like just the enforced version. You could also use the report-only version. Then I would have gotten all the errors at once. Now, I kind of did iterations, allowing one thing, then I had to allow another thing. Like, first you had the scripts, then the scripts tried to get some data, had to add that to connect source. It was loading another script. In this case, if you do it with content security policy report only, you get everything at once. But you can make a policy that you think is good, and you can put it into production. Users will never notice, well, unless they open DevTools, and there is a violation. And you can get all the reports. It's safe. You can push it out there. All your users can test for you. And then you can quickly learn about the problems, and you can just keep reporting on when you enforce the policy. And if there's something going wrong, you will know about it. So I think the reporting is great, but of course you need someone to monitor, and you need a process for what to do if there is a violation. And it needs to be a confirmed violation. Because might have 1,000 page views and 2 reports. And for the 2 reports, it's most likely something going on in their browser, not something going on with your app, because then you would get 1,000 reports. So even though reporting is great, you need to know that there are some directives that don't report. So you don't get any reports if you run it as a meta tag. You also get no reports from sandbox or from upgrading secure requests. And the tough one, frame ancestors. If you want to know who tries to frame your page, it won't tell you for privacy reasons. Sorry. Sometimes I really would like that, but you're not getting it. You're also not getting some of the query string parameters, like password, for privacy and security reasons. So even though you can learn a lot from the reports, what goes wrong in your app, you also have a lot of noise, unfortunately. Like Facebook's in-app browser, see that a lot still. People that want to override fonts, you get a lot of reports, typically like 5 or 10 each time. Sometimes you'll probably get translation services. And you may or may not want to allow those, depending on your threat model. If it's more important for you that users can actually read what's on your page, then allow them. If you want to be super strict, don't allow them. It's your call. It's your threat model. Browser extensions will cause a lot of violations. VPNs, malware, and security products may change stuff on your page. And they may even also change your CSP. Which is quite interesting. So you'll need to verify if it's just one of these or if it's really something going on with your app. Here is the policy. This is the policy from Zoom, the video conference system. It's from March 2020. You know, when we all had to go and work remote, people started loving Zoom, and then some people started saying, well, is Zoom secure? We had the Zoom bombing. Somebody said, well, they have servers in China, and there were other issues. And then there was this. Somebody looked at their CSP, and that got, of course, almost no attention. They have this CSP. They have 2 directives, which means that they have default source and script source, which means everything which isn't script goes to default source. And what do they allow for default source? HTTPS, Safari extension, for some reason, blob, data, and self. So yeah, that's pretty much everything. What it's not unsafe inline for styles. That's kind of impressive. But yeah, that was it. Then they have script source. Let's look at script source. So first of all, unsafe eval, unsafe inline, and blob. So you'll allow anything that's put in inline script, any eval. So when you add these 2 things, the rest of it is kind of pointless. Because you could pretty much not have a CSP when you had this. Of course, you could restrict the ways of, or the possibilities for exfiltration of data and a few other things. But it's pretty much falling apart. But just let's look at it, because I think they have made their policy from looking at reports and, oh, no, we don't want these reports. This is probably a problem with our page. Let's just add this so that everything works for everyone and we get 0 reports. So this probably was something they realized quickly that they need, because it seems like they use some Google Tag Managers or similar things. So they probably need this. This is legitimate. This is things I've seen in other marketing web pages. Yeah, like YouTube, they're probably downright. They have a YouTube video, likely. They have a lot of these things like trackers, and they load code from jQuery, and yeah, things that are common, like makes it easy. We don't have to host it ourselves. Well, not what you would like to do when it comes to security. And then they use a lot of wildcards, which I wouldn't advise to do that for script source. You can do it for a lot of other directives, but probably not here. They have a lot of CDNs. They allow scripts from like any subdomains on the last one, and now from CDNs. And CDNs are typically shared, and they typically have a lot of different stuff. And the bottom red one, Dropbox. Who can add a script to Dropbox and could run it on the page like this? Well, yeah, I think all of you would be able to. Likely a browser extension, added twice for some reason. A security product, modifying your page, beautiful, also added twice. Malicious sites. I did some studies on reports at the same time as this, and I recognized this. Like, why do you want to run scripts from 50million.club? I don't know. How do you know they're malicious? Well, in the report, you typically have the URL to the script. If it won't even allow you to load the script, it's a big red flag. If you load the script and you try to read it and it's fairly obfuscated, and especially the part where you see it's trying to send data, it's so highly obfuscated you can't make out what it's doing. It's clearly malicious. If you take that code, send it from one email provider to another one, and it never arrives because it's blocked, likely malicious. If you see the IP of this site shared with other malicious sites, yeah, it's malicious. So don't just add stuff, because that's not the point of the policy of having a policy is getting to 0 reports. Because what you want to do with the content security policy is to create a strict policy and then just not adjust the policy to make things work. Then you need to adjust your website or your app to work with the policy so you can actually protect your users and have security. And that's the end. A lot of resources. And I will also take questions.
What if we have two conflicting CSP rules, one with metadata and one with the header? So then the browser picks which one?
So the question is, what if you have two conflicting CSPs? So, as I said, all content will now need to pass all policies. So if you have two conflicting ones, like one is restricting some things and the other restricting some other things, everything here will be restricted. So they need to pass both. Did that answer your question?
What if, because one is allowing something and one is blocking something?
So there is no such. Oh, so the question is, what if the one is allowing something and the other one is blocking something? Well, you allow things. So by default, if you have no CSP, you're allowing everything. If you have a CSP and start to implement one of the fetch directives, you like default source, then you restrict everything. So then you allow stuff. So it's not like you can say a CSP restrict this, allow that. It only goes one way. It only goes allow this and allow that and allow. Yeah. Other questions? Okay. Yeah. Can you come down? What's inside an iframe?
Yeah, so the scripts, like if you load an iframe from a PSP, you need to allow those scripts as well.
So what if there's a script inside an iframe that's on your page? Oh, I can't remember. Sorry. I'll need to test it out. Because I think I've tested it out before, I just don't remember the answer.
Because in PCI DSS, if you are loading a PSP or you have a payment service inside your page, then you need to validate all scripts, right? And if they have scripts inside their iframe, will we need to validate those scripts as well?
Yeah, so the question was, so if there is, like in PCI DSS, you have a payment page that you embed on your web page. So in that case, I really hope that the payment provider will enforce a CSP on that level so that you don't have to enforce it on that. But you may need to allow it in the outer frame. I can't remember. Yeah. But you can make some frames and test it out. Other questions? Nothing? Okay, thank you very much.